There are all kinds of rules by which we can construct sequences, but two particular types of sequences dominate in mathematical applications. Those in which pairs of successful terms all have a common difference, which would be arithmetic sequences, and those in which pairs of successive terms all have a common quotient, which are geometric sequences. We'll take a closer look at these in this section. Now, an arithmetic sequence. A sequence is an arithmetic sequence if it can be written in the form A plus D, A plus 2D, all the way up to A plus n minus 1D for some constant D. The number D is called a common difference. Each term in an arithmetic sequence can be obtained recursively from its preceding term by adding D. We're going to be using that quite a bit in example 5. Now, I apologize, we're not going to have a lot of room here, but we should have enough to do at least example 1 in the space provided. Now, for part A, we need to find the common difference. Well, you should see the common difference, we're adding 4 each time. Now, to find the 10th term, A sub 10, that will be, we're going to look up here for the 10th term. So negative 6 plus 10 minus 1 times 4. That will be negative 6 plus 36, or 30. Now for part C, we need to find the recursive formula, or the recursive rule for the nth term. So we're going to use this here. So for part C, A sub 1 will equal negative 6. A sub n will equal A to the n minus 1 plus 4 for n greater than or equal to 2. There is your recursive formula. Now to find part D, which is the explicit rule, what we're going to take, we're going to take the same thing we did for the 10th term. So we're going to take A sub n will equal negative 6 plus n minus 1 times 4, which would be negative 6 plus 4n minus 4, which would be 4n minus 10. So there is your explicit rule then for part D. Number 2, a little bit different because we're dealing with natural logs, but really not a big deal. For part A, we need to find the common difference. Well, the common difference will be ln of 6 minus ln of 3. Going back to your logarithm rules, that will be ln of 6 over 3 or ln of 2. For part B, the recursive, or the 10th term, A sub 10, and if you look back, it'll be our original term plus 10 minus 1 to the, or times ln of 2 times our difference. We're going to have to do some simplifying here. So it'll be ln of 3 plus ln of 2 to the 9th power. Now, since we're adding these logarithms, really this will be ln of 3 times 2 to the 9th power. 3 times 2 to the 9th power will be 1,536. There is your 10th term. Now for part C, your recursive formula, A sub 1 is ln of 3. A sub n will be A to the n minus 1 plus ln of 2 for n greater than or equal to 2. Now for part D, This is where it gets a little tricky. A sub n, we're going to go back to the beginning, will be your original plus n minus 1 times our common difference, ln of 2. Now we can simplify this. To just like that. Now, because you're adding two logs, they have the same base. It'll be just like that. So there's your part D. Now number 3, your common difference is 4. It's going up by 4 every time. For part B, your 10th term will be your first term plus 10 minus 1 times 4. So 6 plus 36, which equals 42. Your recursive formula, a sub 1 is 6. A sub n will be a times the n minus 1, or sub n minus 1, plus 4. This is for all n greater than or equal to 2. For part D, a sub n will be my first term, plus n minus 1 times 4, which will simplify to 6 times 4n minus 4, which will really be 4n plus 2. So a sub n will be 4n plus 2. So there you have it for arithmetic sequences. Now, when we're talking about a geometric sequence, now a sequence a sub n is a geometric sequence if it can be written in the form a times r, a times r squared, all the way up to a times r to the n minus 1 for some non-zero constant r. And that number r is called a common ratio. Now, each term in a geometric sequence can be obtained recursively from its preceding term by multiplying by r. So it's going to be a sub n equals a sub n minus 1 times r for all n greater than or equal to 2. Now, when we look at example 6, for each of the following geometric sequences, find the common ratio, the 10th term, the recursive rule for the nth term, and then an explicit rule for the nth term. It's going to be just the same as we did for arithmetic sequences. So A, our common ratio, r will be 6 divided by 3 or 2. There is your common ratio. For part B, we need to find the 10th term. So what we're going to do, we're going to use this right here. It's going to be our first term times the ratio to the 10 minus 1. Well, really, that will be then 3 times 2 to the 9th, 3 times 2 to the 9th, that will be 1,536. Now, the recursive rule will follow right from here. There's our recursive rule. So we're going to really put first, a sub 1 is 3, a sub n equals a sub n minus 1 times our ratio, which is 2. So that means a sub n will actually equal 2, a to the n minus 1, for n greater than or equal to 2. So there's part C. Part D is the explicit rule. Now the explicit rule again follows straight from our first part there. So a sub n will equal my first term times my ratio to the n minus 1 power. And there is your explicit rule. Now, if you look at number 2, we have 10 to the negative third, 10 to the negative first, 10 to the first, yada, yada, yada. So our common ratio will be 10 to the negative first divided by 10 to the negative third, which is really 10 to the second power. Our part B is the 10th term. That will be our first term times our ratio to the 10 minus 1 power. So really that'll be 10 to the negative third times 10 to the 2 times 9, which really simplifies to 10 to the negative third times 10 to the 18th, which is 10 to the 15th power. There is our 10th term. Now for part C, we need the recursive formula. Our first term is 10 to the negative third. So a sub n equals a to the n minus 1 times our ratio. So that means a sub n will equal 10 to the second a to the n minus 1 for n greater than or equal to 2. There is our recursive rule. Part D is going to be our explicit rule. So a sub n will equal our first term times our ratio to the n minus 1 power. That will actually simplify to 10 to the negative third times 10 to the 2n minus 2, which means when you add your exponents, 10 to the 2n minus 5. So there's our explicit rule. We're going to skip number 3 right now because it's just like number 1 and move down to example 7. Now the second and fifth terms of a sequence are 3 and 24 respectively. Find explicit and recursive formulas for the sequence if it is arithmetic and geometric. So this is like a 4-part problem here. So this is if it is arithmetic. So what we're going to have, our second term will be our first term plus d, and that is equal to 3. Our fifth term will be our first term plus 4d, and that's equal to 24. Now, I get that straight from here, a plus n minus 1 to the times d. So our fifth term would be a plus 5 minus 1, or 4, times d. That's where I get it from. Now, what we're going to do, we're going to subtract our fifth term minus our second term. What that'll do, that'll give us 3d is equal to 21, which means your common difference, d, is 7. Now to find a plus 7 equals 3, which means a1 will equal a negative 4. So your a sub 1 is negative 4. For your recursive formula, a sub 1 equals negative 4, a sub n equals a sub n minus 1 plus 7 for n greater than or equal to 2. There is your recursive formula. To find the explicit formula, our explicit formula will be a sub n equals our first term, which is negative 4, plus n minus 1 times 7. That will simplify to negative 4 plus 7n minus 7. So that means a sub n will equal 7n minus 11. There is your explicit formula. Now for part B, we need to find geometric. So this says the second term will be the first term times r, and that equals 3. Our fifth term will be the first term times r to the fourth, which equals 24. Now you get that straight from our chart up here, circled in red. Now what we're going to do, unlike the arithmetic where we subtract, we're going to divide Judging by our math skills so far, you should know that the a's are canceled out. We'll be left with r to the third is equal to 8, which means my common ratio r is 2. Now to find our first term, we're going to plug it right back in here. So that means a sub 1 will equal 3 halves. That means my recursive formula will be a sub 1 is equal to 3 halves. A sub n will be a sub n minus 1 times my ratio. For n greater than or equal to 2. My explicit formula, a sub n will equal my first term times my ratio to the n minus 1 power. And there's your explicit formula. Now we are not going to do D or number 2 or example 8. And again, remember your homework, you do not have to do numbers 33 and 36 in the homework.